Multiplying binomials. So remember, binomials are polynomials with just two terms. So notice with all these examples, in the parentheses, there's two terms. So we multiply these two terms times the other two terms. So we're multiplying binomials here, okay? So unlike the previous lesson, we don't just have one term to multiply into the other parentheses. Now we have two terms to multiply in the other parentheses. So this is how this works. So this x here is going to multiply to this x and this 3. We're multiplying the x to the other binomial. And we're also going to multiply the 7 to the other binomial. But let's just do that first. So the x times the x is going to produce an x squared. Zoom in a little bit. And the x times the 3 is going to give us a 3x. So I distributed the x to the other parenthesis. Now it's time for me to distribute the 7 to the other parenthesis. So the 7 times the x there is 7x. And the 7 times the 3 is 21. So we're multiplying the terms in the one parentheses to the terms in the other parentheses. But we want to simplify this now. So we have a 3x plus a 7x. I'll underline those. These can combine. 3x plus 7x is going to be 10x. So let me write x squared first, plus 10x plus 21. Let me show you b. So we're going to distribute the 2x minus 5 to the x plus 4. Remember, distribute is just multiplying. So let's first distribute the 2x. So the 2x times the x would be 2x to the second. The 2x times the 4 would be 8x. So we've distributed the 2x. Now let's distribute the negative 5. Negative 5 times x would be negative 5x. And negative 5 times 4 would be negative 20. And now let's clean it up and combine like terms. So the 8x and the negative 5x, those will combine. They'll combine to 3x. But let's write the 2x squared again. Keep this in standard form. 8x minus 5x is 3x. And then we still have minus 20. Let me show you a couple more. So again, distribute. We're going to go to the 3x times the 2x. 3x times 2x would be 6x to the second. The 3x times the negative 5 would be negative 15x. So we've distributed the 3x. Now let's distribute the negative 9. Negative 9 times 2x would be negative 18x. The negative 9 times the negative 5 would be positive 45. Combine like terms. We have our negative 15x and our negative 18x. So let me first rewrite the 6x squared. The negative 15x combined with negative 18x would be negative 33x. And then we still have the plus 45. Let me show you D. D is a little unique because this first term is x squared. So if we do an x squared times an x, it's x to the third. An x squared times 6, it would be 6x squared. The negative 5 times x would be negative 5x. And the negative 5 times positive 6 is negative 30. So what makes this unique now is that maybe you see it, maybe you don't, but there is no like terms to combine. We have an x to the third, an x to the second, an x to the first. There's no like terms, so we're done. I'll let you try E and F. Now I want to do one with a couple variables, one that has an x and a y. So I'm going to actually do H. I'll let you do G. So I'm going to first distribute the 3x. So 3x times 4x would be 12x to the second. The 3x times the negative 2y would be negative 6xy, right? They're different variables. So a 3x and a 2y, and we get that negative 2. The 3 times the negative 2 is negative 6. But the x doesn't go with any other x in the other term, and the y doesn't go with anything over there. So we're just going to write it as xy. Same thing here. When I do 7y times 4x, 7 times 4 is 28. But again, we have an x and a y. Those don't combine or anything. So I'm just going to write xy. And then the 7y times the negative 2y would be negative 14. And then a y times a y would be a y to the second y squared. But in this one, there are like terms. Let me underline those in green. This is like with this because they're both xy. They both have xy variables on them. So I still have my 12x squared. Let me rewrite that. But a negative 6xy plus a 28xy is going to be a 22xy. And then I still have my minus 14y squared. So let me move on here. Okay. So these ones look a little bit different. And a lot of times students make mistakes on this because they're not really understanding what it's asking. They just think, oh, it's that term squared, so I just square what's inside of it, and they miss out an important component. Remember, when you see something that's squared, you're saying multiply it by itself. Multiply by itself like twice. Just multiply by itself. So I'm going to do k. I'll let you try the other ones, but I'm going to show you k. So when I have 5x plus 3 squared, what that means, and you need to write it out this way, what that means is a 5x plus 3 times another 5x plus 3. So you want to write it out like that. A lot of times students just think, oh, 5x would square it, that'd be 25x squared, and then take the 3 square it, that'd be 9. But you're missing out the critical middle part. So you want to rewrite it out like this, and then just distribute. Okay, so we got the 5x times the 5x, that would be 25x squared. A 5x times a 3x would be 15x. Then this 3 times the 5x is another 15x. And then 3 times 3 is 9. Then the 15x plus the 15x would give you 30x. So I have 25x squared plus 30x plus 9. Sorry, I kind of went that one really fast, but we have been doing a number of those already. It's just, I think just that kind of beginning step here that I'm highlighting here, that is, that's really what I wanted you to understand there. So I'll let you do those similar ones like I, J, K, and L. Now let me do one of these last 4. I just want to make sure you understand what kind of happens when, we kind of have, if you notice, they all kind of look similar, right? We have a x plus 6 and an x minus 6. Then n is an x minus 3 and x plus 3. And then O is a 2x minus 5 and 2x plus 5. So all look quite similar. And all these kind of have something that kind of special that happens with them. So as we kind of distribute, so x times x is x squared, and x times negative 6 is a negative 6x. And then positive 6 times x is a positive 6x. Positive 6 times negative 6 is negative 36. So just what we've been doing. Now, the only thing that's unique with all of these is that you'll notice like negative 6x plus 6x, those combine. But what they combine to is 0x, which is just 0. So we don't need to write it. So these kind of just cancel out, and we're just left with x squared minus 36. These just kind of, I'm going to slash these in red. Those just kind of, cancel out. So these ones are kind of unique. But you go ahead and do the rest.